Let me introduce you while you are just uploading it.
I think, can you see my slides?
Mm-hmm.
Okay, very good. So please go ahead.
Okay. So please welcome Yazdan Pedram Razi. And the title is Constructal Law. Please go ahead.
Thank you very much. So I think the things that I'm going to talk, this subject, constructal law, if you did not heard that, don't be surprised. It has only 20 years they are working on that. And in the beginning, no one understood what that person that I will mention was talking about. But I will show you it is very interesting and very applicable. And about myself, what I want to tell you, I am from San Jose State University. I am part-time lecturer. At the same time, I work in industry too. And the thing that you need, this is my email. Please use my email, send your everything that you want, your comments. And that's the thing I can tell you. So after this, I will talk about what topics I have. The definition, I will talk about constructal law, characteristic of constructal design, some historical aspect of constructal law, and constructal law in different applications. So this is the thing that, you know.
Yazdan, would you like to make your talk full screen, or do you want to keep it?
Yes, of course.
Okay. We don't see full screen right now.
Well, let me check that if I can do this full screen.
If not, it's all good.
Maybe you can do the slideshow or something.
No, I know. Because, you know, this thing is here. I will do something like that. Like this.
Oh.
Is it so?
Yes.
Okay, very good. So what I'm going to talk about is what is constructal law? So given the fact that today we are talking about women in mathematics and everything, so I have put the picture of the pioneer person, it is Yazdan Pedram, and the second person, Sylvie Laurente, that was another major contributor to this subject. Interestingly, I was in France, and, you know, my apartment was 2 blocks away from Sylvie. So that was something very interesting. I think it is a chance. So first thing first, what is this constructal law? This constructal law states that for a finite size system to persist in time or to live, it must evolve in such a way that it provides easier access to the imposed or global currents that flow through it. Well, I should tell you, the first time, it was in 1998 that Adrian sent this to me. I was a student. I didn't understand anything, although I know all the books of Adrian by heart. So after this, I thought, okay, so what exactly this subject may be. So I began that. So what are characteristics of a constructal design anyway? The first thing is that it can be predicted by theoretical, experimental, or numerical methods. It is not fractal. This is most important thing. Can evolve during the time. It's not rigid. And finally, gives us a shape that is very flexible in incorporating other constraints. And number 5 is leads us to a better design or something very, very optimized. So how this came to bring to Adrian's idea, apparently when he was correcting the student's paper, that I know many of you do this, and you find this very, very boring, he got this idea. I put one of the work that he had done. It is about, again, some of them it's very, very in application in heat transfer. So, you know, we have 3 pictures here, and as you can see how we can find the optimum shape. So as you can see, the left side, they are much apart, these blocks that they are heat generating elements. And when they are much more packed together, it's very hot. So this red color means hot, but there is an optimum spacing between them. Now, having said that, how we can find this optimum space? That was the whole idea. So that said, so the question is why I am interested. Well, it covered all my interests because, you know, I was in art, I was in engineering, I was in mathematics, I was in physics, and I was also in industry. So I could serve on different domains. The other thing, it helped me to motivate my students because many of the problems that I had encountered, some students, they did not understand what is the application of that. So with this law, I tried to tell them what exactly we are going through. So as you can see, it is heat transfer, my major subject, thermodynamics, optimization, correlations, process engineering, and pedagogical aspect that I will come, and some predictive aspect, philosophical if you want. So how these things evolve through time. So, you know, the person who pioneered that, Adrian, began with entropy generation. These are many topics in engineering, thermodynamic, and heat transfer. So a little bit, maybe it is far from what you think, but it's very easy. It's not something much apart from what you are doing. Determine the heat loss, exergy analysis. I think maybe you didn't encounter what is exergy, because certainly you know what is energy, but what is exergy. So that is another thing that, you know, if you take a look at first law of thermodynamics, it is a very idealistic aspect. Every kind of energy, they can relate to each other, they can transform to each other. But the second law, no, this is not the case. The heat is much important and work is much important than heat. So that's the thing, meaning that we can transform all work to heat, but we cannot transform all heat to work. So this is something that comes, the exergy analysis, that is the analyzing what we can do to optimize heat. After that, there are some tools that we use. It is scale analysis, as I have mentioned yesterday in Lewis Carroll, Alice in the Wonderland. This is the scales that he is playing with scales in the story. And then it is about optimization, meaning how to increase, how to decrease. And finally, geometry optimization, because, you know, we are living in a world, everything should be very small. For example, if you have a charger, if a charger is very, very big, you cannot put it in your bag. So finally, how we can correlate this, how we can correlate the problem to the geometry. So this is the photo that, you know, when I came to the US in 2006, when I was above the air, I was looking at these two figures. I will tell you what exactly is the historic of that, but comparing these two figures, what you will understand from them. Think about that, because, you know, all of you are scientists, you are researchers, you are not students that much. So these originally I have created for my class. So many of these slides I have deleted because, you know, I wanted to give some ideas only. And it is not something, question and answer things that, you know, I don't want to anyone who have some ideas that, you know, you are students. No, you are all researcher, the same, maybe better than me. So now I will tell you what exactly it is. It was the left side, it is the photo of the San Francisco. And the right, it was from Toulouse when I came. You know, there is a quite difference between these two things. The left side is parallel line, and the right side, it is not. It's a sprawling thing. Why? So that was the question when I was coming, I asked myself. So you can see this is the constraint that we have. Because in the US, given the fact that you take a look at the surface and the area, you don't have the problem here. But here in Europe, in your right side, we have the problem of space. So if you have lived in Europe, you see that the apartment there is very small. Everything is small. And on the left side, it is not the same thing. The other thing was when at first I was in the airport, I wanted a cup of coffee. The coffee they gave me, I was really panicked. And I said, why this is so big? But the guy told me, well, you are in San Francisco. If you go to Texas, this is two sides of this. So that was the first encounter. When you change the size, what would happen to you? For me, coffee is also very small. Still, after from 2006 to up to right now, it's more than 15 years, I still, when I am eating coffee, it is a small size. So some early development of constructal law. So it is something that everyone knows that. If you take a look at your right, this is a wrench, and this comes from a hand, if you take a look. And if you take a look at the other side here, you will see so long, and then this is the thing that I will discuss, how everything branched here in your right here. So some early development, again, I'm talking, this is taken from one of the article that Adrian wrote. So this is about the relation between speed and weight of something or body mass. So as you can see, we can have a line here and the speed exactly. So this is something very interesting. The same thing can happen for mammals, on everything, for fish, for the things that there are in sea and oceans. So that was very interesting when we have something, a correlation on this. So some landmarks that I put here, for example, you can see that, for example, it began from many, many years back up to now. So you can see the landmark of when we have agriculture, then we have printing here, and then when we had jet propulsion system, internet. So you can see how everything has evolved through time. And here, I have a little bit changed that. So the things that, Shana yesterday was talking about, if we are in the diamond, what the time will happen. So that is very interesting thing. But, in human level, we can see what's going on, how we are developing. And here, from walking, we are going to something like electric vehicle. Original, the figure was not electric vehicle. It was an automobile. So I changed that to electric vehicle. So again, coming with what tools we are using Constructal Law. So again, scale analysis, and I put Alice in the Wonderland, the book that I think it's very interesting. I have read this many, many times. I think more than 100 times I have read this book. And every time I read it with a fresh eye, I can find something more interesting. And the other thing is geometric optimization method, GOM. So one of the most interesting problem, this was something that published in 1998. It is heat conduction in a very, very interesting geometry. It is a slab, and this heat generated in the middle of that. And we have some very, very expensive material to spread heat, some high conductivity material, and some material that are not very good. So the first construct is this one. Then we will try other construct. So finally, the 8th construct will become something like that. All these things you go through, that the first thing that I showed there when you were comparing to lung. So after this, I will go to thermal optimization. This problem that I'm talking, this is the problem that it was in one of the work that I did myself. So the thing is that what steps you should go through, specify your objectives, define your constraint of the problem, and impose boundary condition or initial condition. So physical model that I have used is maximizing heat transfer from an isothermal horizontal cylinder. This was something in refrigerator you can see. So as you can see, this is the geometry that I have used. It is cylinder, it is parallel plate, they are insulated. The problem is natural convection. The reason that I use natural convection because it is something natural. It is something that it is created with heating that comes when we have nothing else, not forced fan or anything. So these are some examples that I put very, very exactly. But here again, we came to the shape. So you can see if we have the walls very, very far from each other, they don't have anything. If this is very close, you will see we'll have some heating issue. But there is an optimum value that it is E over D equals 3. So after this, I have some examples here because, the problem of time is very important because, I don't want to waste your time and I want to finish that. There are some examples that, I have from one job to another job to another job. So from each of my job, I have put one examples here. The thing that, it comes to the thing that we discussed. One of them was about LED. So, LED, this is used for having light, very concentrated, but the problem is it becomes very heated up. So as you can see, one of the things for heat sink, it is used to cool it off. So this right things, it is some new design that you can see. This is some constructal thing. It is exactly the same branching things of the trees that it is used. And there are lots of things, how many bifurcation you can have this, and how many you will have on resistance. I have put it here. Everyone can see that. So when example, you have many, many things here, what will happen if you have 2 or 3, what will happen? And finally, what you will have here as the best result that you will find. And this is some artistic form, because today everyone was talking about artistic forms. This will become some artistic form if you want. So the other thing that, most of you you discussed about that. I think one of the things that every one of us we like space is that I think today Eastern was talking about some space, and she was wondering why she liked space. I think going to space is something idealistic idea. Everyone who thinks about that is thinking very, very about perfectionist world. If we want to build a world, so this was the thing that I did on Constructal Law. These are some of the things that, it is a conference that I have presented this. This is not important. The interesting thing is that things that, the structure we can find and the thing that we can find for heat transfer. As you can see, if we use these kind of things in microgravity, it will increase heat transfer. One thing I should add here, because you will wonder, well, we are microgravity, how on earth we will have some convection current. Do not forget, when you are in space station, this was for space station, there were some kind of residual acceleration, because here on Earth, we only have gravity, but unfortunately, it masks everything existing there. But there, when, for example, the astronauts, they walk, or if there are some equipment for cooling there, there are some residual acceleration. That can create some kind of convection movement. So these are the things that, it's something that that it is. But some biological application of the Constructal Law. This is about COVID-19. So, every one of us knows that if we sneeze, direction, everything is important. How it is, I don't know if you have gone to any places. Here, I used to go to library. Every time I go, the person there's a, please protect you, everyone. You should have your mask well in place. So every time I go there, I will become a little upset. And I want to tell you, well, you don't know the whole idea. So this first thing, how this process began, it is experimental. This is a person who sneezes, how everything will be there, how long this distance will be there. So this is something that when everyone is talking, well, protect everyone, this is the way everything will evolve. So if you are protected, it is not that much bad. So here, for example, when we have something to protect us, what will happen? So you can see how everything has reduced, how everything, when you are contaminating, it is done. So you can see how mask will do this, how when you have a screen will change everything. And the left side, it is infrared camera, infrared image. And everything like this. So, there are some studies. I have written some of the papers that you can take a look at that. Because normally the thing is that sometimes I like something to do after that and find everything. Sometimes I cannot find. So because of that, I put everything if anyone likes that. The other thing that I want to talk about is some countermeasures on COVID. This is supermarket. The idea of supermarket is not something new, but the thing that, I saw that they have done was very interesting. So exactly, you can see a supermarket. It is simplified like that. So what they did, first thing first, for example, in the place that I am in San Jose, they have restricted the access to that. Only one place we can see. We can go there. Then, as you can see, they have reduced the distance between people. And the other thing is that you can see how the distance here changes and how everything, when you have a cart with yourself, will pass here. So these are other things that you can see when everything was developing. I went there and took a picture. I think some of this will become history. For example, it was done in restricting directions. So only in one direction we could go to a supermarket. The other thing was that the places that everyone would be distance from each other. Again, when I was looking at that, this is nothing more the optimal spacing between things. So as you can see, with all these countermeasures, how everything evolved here. So that was something very interesting. So the other thing that I want to talk, again, this came from HoloLens. This was something, I was one interview and the person didn't know why I was there. So I use that as something that I can use for my things on constructal theory. Because the idea is that, well, we talked about construct theory, but is it possible to have virtual constructal theory, virtual constructal law? So the answer is yes. We can have this. And if you have used cell phone and everything, you will see that this is the same thing. You have some constraint there too. But I think this can be used as some kind of very interesting thing to teach the things. And this brings me to the thing that, the last part. This is how we can use the online teaching. So, I wrote for you the fourth construct that, I have gone through that. The first construct that to prepare your SLOs, course lectures, every one of you does that. The second one is that how to add engagements, break rooms, polls. So you check what you have done. The third construct is that the students will go, okay, that online we don't understand. So you'll add other things, whiteboard sessions. So meaning that you write down something, solve the problem, and show to students, and handwritten exercises. Because, given the fact that the students here, they want some quality and quantity at the same time. You write this, when you are writing this, the time is very important. You can finish that. And after all these things, fourth construct is to create some small groups for online sessions and go very slowly. Because, I've got some comments of students that I'm very fast. So with all these things, you can create something very interesting called specifications grading. I don't know if you have used it. This is very interesting. This is multiple tests and retakes, because with this, you can do something. The students will come and become really the owner of everything in the class. And one last thing for this, know that it is a 100 round match. If you lose one, don't worry, everyone the same thing, but the one who stays to the last will the one who will win. So in conclusion, by Constructal Law, we may solve scientific solution to fundamental as well as industrial problem. One should identify objectives as well as constraint, and Constructal Law can provide terrestrial as well as extraterrestrial solutions. I think for extraterrestrial, I was the only one at the first time I thought about that. Constructal Law can be direct us to developing new technologies. So as I have talked about that, the HoloLens was something very interesting. And we can use Constructal Law in our classes. So, you have all of us, you have been teacher, you are lecturing, everything. But this thing can be used there too. And this will bring me to the last, as we are very close to Halloween. So thank you. And I hope that you will give me your comments. Thank you very much. Shana, I hope that I am on time.
Thank you so much, Yazdan.
You are welcome.
You're on excellent time.
But my slide is 3 times. After this, I have at least 3 times of this. So I put something only 50 that I can finish.
I actually have a question.
Go ahead.
Yes, so you spoke of the 4 steps of constructal law.
Well, it can be 4 or it can be something. It depends, because if you take a look at that, it is very iterative. It depends.
Iterative.
So, for example, if you take a look at these simple examples that you have a classroom, you can understand that, because first you do something and then you see what's the problem.
Okay.
Because when you are optimizing, it is impossible in the first step we can find our objectives. So you need much more iterations and try to find this. For example, classroom is the one. The thing is that I have done myself, because I'm preparing a paper on specifications grading, and I was not satisfied with the thing that I have read. So I want to tell guys, this takes time first, and if you got some negative comments, don't be disappointed. This takes time. And this 100 round match, I am, this is something, very boyish things. I like boxing. So, if you take a look at that, in a match, boxing match, it is not the first round that decide. You should be there and you should not be knocked down. That's the most important thing, and go ahead and go ahead. But yes, it takes time, and because of that, it can. But at the same time, it is possible that, it depends on what you want as your objective. You can stop at second construct.
Oh, I see. So it's a process. This
It's
is
a
like an
process.
approach. It's
Yes.
an approach to a problem.
Yes, exactly. It's an approach.
Oh, I see.
Problem approach.
I see.
I have a question. Excuse me, Yazdan. So I think you mentioned this being like an iterative approach or something. And so, how are you measuring like your steps in your iteration? So is it sort of like class to class or semester to semester? So an entire course over the course of an entire semester or term is one step in your iteration, and then the next step is like the next semester's course? Or is this iterative process happening like sort of inside of the semester itself, where maybe like the assignments and the activities that you have the students doing are themselves like evolving over some iterative process inside of the same semester? Does that make sense?
Yes, of course. Dan, thank you very much. It's a very, very good and timely questions. So I will begin from the first thing that, I can tell you about. This was some theoretical problem. As you can see here, you mentioned that how you measure that. I will begin with that, then I will go to the last example. So for example, here you will see that if you don't have any wall, we have a characteristic thing called Nusselt number. This is some heat that is normalized. It was around 3. So my question was, is it possible to increase that 3 to some other values? So if you can take a look, yes, it would be possible. For example, here, it would be 4. So meaning that this was some criteria for doing this. The other thing would be the space. So if, for example, somebody asks us, no, you don't have that much space, you can decrease that, you will have the other one. So it depends what you define as your objective. Now, again, something very, very common here that we have, that things that, I was talking about classroom. So basically what I gauge everything was based on the comments of students. For example, this semester I was teaching pre-calculus. I had 5 negative comments. It was something like that. We didn't understand anything you teach. And I do, okay, fantastic. So I went again and again. And the second one, I didn't have that. And again, my second midterm, I had people who were giving me some comments, constructive comments, meaning that, Professor, can you do slower on difficult problem and faster on easy problem? That was something very good. The other thing was, Professor, can you provide something to us that we see your hands solving a problem? Because we are accustomed to that. Okay, no problem. Because of that, I put, for example, whiteboard sessions. So, everything is based on the comment of students. This is one-on-one. And also, when I had the midterm, I pushed them to write something for me. So, it is not that easy because, it takes a lot of time from me. And I'm using these comments they have on doing some things this time that it is on, what's the name of that? It's not whiteboard. It is something that small by small, I can put all these sessions that on the one slide to talk about them. Anyway, I'm going to use what exactly it is there to use all things that it is my arsenal in my to put it on the table that I tell them first thing first, I heard what you told me. And second thing is I'm doing this that you can understand. But at the same time, it is something that you mentioned, David, because, when you have a poem, the first time it is not what you want. The second time you try a little bit better, the word. The third time you will try to put some mathematics into that. The one that, for example, Rachel was talking about, that was something like that. Because I think at first you need something. Or if you want to talk, you need some backbone in the beginning. Then it will come adding to that. So the first thing is the backbone. And after that, the other things. I did not talk about that. I had something. I did not talk about this. This is some constructal thing that I did in one of the application that I had. I don't know. It is something here. I will find this. It was some charger that I was designing. I can show you. This is very interesting. Here, this is a charger. This is another generation of charger that you are using. And one thing I should tell you, if you are using Apple charger, I am the designer of that. So the whole idea came from the thing that I was doing, and this is a visual one that I was using. And if you take a look, the transformer I was designing was here. This is another thing design I had when I was leaving the company. You know, everything is around this transformer. The electrical architecture is around this transformer. So this has a back form, and I have written something here. Here, comparative appearance of cities around rivers. So all the cities that you can see normally, they are built around a river. Why? Because they have much more information. If you take a look at the first things that I was using here for when I came here to the US from France, and that was the river in Garonne. You can see that, how the difference, these two things is that. This is the Garonne. It is very simple, you know, don't think that Garonne is a very strange word. It is the river with sound. So this is the thing that you can see, because, you know, in Europe, normally the cities are around some kind of rivers. So that was the thing I can tell. I hope I have given you the answer that you needed, David. But if you didn't have, you can send me email. I can find other method to explain what is on my mind.
That's good. Yeah, thanks. Thank you.
Yeah, Nico, I think we should reconvene in the main room and then ask Yazdan and Daniel, because I totally want to pick their brains later. It's like, but Beth is amazing, and I want to start right at noon. Yeah.
Yes. So thank you, Dan, Rachel, and Yazdan. We upload again to thank all your sharing. And now we're going to move back to the main room, and we will see you there.
Okay. Thank you.
So great. So great.
Okay.
Thank you.